M1, February-March 2021 paper. Let's look at the first question. The first question is, two particles, P and Q, of masses such and such respectively are free to move in a horizontal straight line. Let's start underlining. There is a particle P, there is a particle Q. These are their respective masses. It's a horizontal straight line on a smooth horizontal plane. P is projected towards Q. P is projected towards Q with a speed of 0.5 meter per second. Now it all depends how we are going to draw that diagram. Speed to the right, I label it as positive. Speed to the left, I label it as negative. So I have drawn two particles and the rule is the same. Naturally, this is a question about collision and all these things and momentum. So let me draw it again over here. One more particle and another particle. Now we all know that drawing a diagram, it's not necessary, but naturally it's useful. So this is particle P, this is particle Q, this is particle P, this is particle Q. And then it says P is projected towards Q. So it's going towards Q with a speed of 0.5 meter per second. At the same instant, Q is projected towards P with a speed of 1. So look at the direction of the arrow. This is 1 meter per second. Q comes to rest in the resulting collision. Therefore, this is at rest. And find the speed of P after the collision. We don't know. Let me label this thing as V. The masses are 0.2 kg, 0.3 kg, 0.2 kg, 0.3 kg. Momentum before collision is the same thing as momentum after collision. Therefore, 0.5 into 2 plus 0.3 into -1. Why? Because it's in the opposite direction. Rightward is positive, leftward is negative. This is 0.2 into V. This is 0.3 into 0. 0.5 into 2 is 1.0 minus 0.3 is equals to 0.2 V. 0.7 divided by 0.2 equals to V. Therefore, V comes out to be positive 3.5 meter per second. That means the direction that you took initially, that is the correct direction. If the answer were to come out to be negative, that means it's actually traveling in the opposite direction. That is the answer for the first part. Now, in this particular paper, what else will I do? I'll go to the mark scheme. Not actually the mark scheme, the exam report. And I'll focus a bit on that. So this is for paper 4, mechanics. Let's ignore the key messages for right now. I'll come back to it at the end. Let's hope so. Let's focus on particular questions, specific questions. Comments on specific questions. Question number 1. The question was successfully completed by many candidates. The definition of momentum was known by almost all candidates. However, an error that was frequently seen was not to consider the fact that the initial velocities and hence momentum of the two particles were in opposite direction. That is the main thing. That is what the examiner is checking. This often led to a sign error in the momentum. Naturally, it would. The final answer was in some cases given as a negative value when in fact the question asked for the speed which must be positive. That is second good thing. That maybe my answer came out to be negative. I'll ignore the minus sign and I'll simply state the speed. If the examiner were to ask the direction, then I would mention that particular direction. So that was question number 1. Let's move to question number 2. And also let me label what is the topic of each question. So this first one is about momentum. And let's look at the second question. The second question is, a car of mass 1400 kg is traveling at a constant speed up a straight hill inclined at alpha to the horizontal. Value of sine alpha is given. There is a constant resistive force of magnitude 6 Newton. Power of the car's engine is such and such. Show that the speed is this much. And then furthermore, they're asking about this particular question. It's all on one page. So basically, it's a standard question about power, and F is equals to ma. Resultant force is mass into acceleration. Now, let's start underlining. Mass is 1400, constant speed, straight hill, alpha to the horizontal. Now, straight means the surface is straight, but it's an inclined plane. That's why the value of sine alpha is given. There is a constant resistive force of magnitude 600 Newton. Power of the car's engine is this much. Show that the speed of the car is this. Draw a small diagram. Show the inclination. Show that particular particle. So that particular particle is somewhere over here. And then label the things. So therefore, the weight component is going down. That is mg sine alpha. The value of sine alpha is given. So nothing to worry about the accuracy. What else is there? It's traveling down. It's traveling up a straight hill. So this is up. That means the engine force is acting up. So what is the force produced by the engine? That is power divided by velocity. That is what you are looking for. And what else is there? There is a resistive force. So that resistive force is 600 Newton. And it's traveling at zero acceleration because it's traveling at constant speed. So technically, the upward forces and the downward forces are equal. That's one way of stating the truth. Or you can write forward force minus the weight component minus the frictional or the resistive component is mass into acceleration. That is 1400 into 0. So this way you will find the value of V. That is the first part. Then it says the car moving with a speed of 11.25 comes to a section of the hill. So now it's a section of a hill which is inclined at 2 degrees to the horizontal. So even more inclined. Given that the power and the resistive force do not change, find the initial acceleration of the car. So this time no need to draw the diagram. Power is still the same, 22,500 over V, which is 11.25, minus the weight component, which is 1400 into G into sine alpha, minus the resistive component, which is 600. That is equals to mass into acceleration. Wait a minute. That is, now the acceleration has changed. So this is not 0.1. So therefore, the inclination has changed. So therefore, this is sine of 2 degrees. So this way you will find a new value for acceleration. This thing is done. Let's have a look at the specific mark scheme examiner report. Question 2. Most candidates made a very good attempt at this question. Almost all use the fact that since the car is traveling at constant speed, driving force is the sum of resistive and whatever. As the power of the car is given, the speed of the car can be found by applying the equation where P is the given power, F is the driving force, V is the required speed. Very few errors were seen in solutions. If it is, however, a case where the given answer is only achievable by using the value of acceleration due to gravity as G is equals to 10. Now this I have seen even on the mock exam that some people were using 9.8 or 9.81. In this syllabus of ours, we have to use G as 10 meter per second square. The question involved the application of Newton's second law since acceleration is required. Actually, in the first one, of course, Newton's first law or second law is still applicable. The forces acting on the car in this situation are the same resistance, but a different component of the weight due to the change of the angle of the hill. mg sine theta, first it was 1 degree, now it's 2 degrees. The combination of these three forces produce the required acceleration. Although many excellent attempts were seen, some candidates forgot to include the driving force in their solution. As the sign of the angle is not exact, this is the CAIE where answer must be given to 3 significant figures. A number of candidates produced very good solution, but then only gave the answer to correct 2 significant figures. Let me add my 2 cents to it. That is work in for SF, so that the final answer should be given to 3SF. That is something even more important. Let's move to the third question. Now in the third question, it says a particle of mass 0.2 kg is held at equilibrium by 2 light and extensible strings such and such. P is a fixed point on the vertical wall, R is a fixed point on the horizontal floor. The angles which strings make are such and such respectively. Find the tension in the 2 strings. So now this is a question about equilibrium of forces. So this is an equilibrium question. There are 2 strings, so 2 different tensions. So first of all, let me label this tension like this and the other tension as like this. Now there are 2 tensions, therefore these 2 tensions are, the first of all, there is a tension like this. Let me call this as T1. There is a tension like this, that is called T2. Now I have drawn this in opposite direction. Why? Because T1 is trying to pull it up, T2 is trying to pull it down. What else should be included? We should include the weight of this thing, that is 0.2 g. So this is 0.2 multiplied by g. Now we naturally need to resolve it. So let's resolve the component. This is horizontal component, this is vertical component for this, and this is horizontal component, this is vertical component for this. So therefore this is T1 cosine 60, this is T1 sine 60, this is T2 cosine 30, this is T2 sine 30. So all this labeling takes time. And it's in equilibrium, so horizontal forces and vertical forces. Horizontal is T1 cosine 60 is equals to T2 cosine 30. Vertical forces, T1 sine 60 is up, is equals to 0.2 into 10 plus T2 sine 30. Now it does not say so that you have to work in the exact form or anything like that. So just comfortably work in decimals. Just for the first part, let me see if I can work in exact form. Yes, I can. T1 multiplied by half. This is T2 multiplied by root 3 over 2. So the 2 cancel. Basically, T1 is T2 multiplied by root 3. And then I can substitute and then later on use a calculator. So that's my choice. So this thing is easy. Again, let's go to the mark scheme. Question number 3, it says the question was well answered. Several possible approaches. Most candidates use the method of resolving the forces acting on the particle horizontally, vertically. That's what we did. These 2 equations involve 2 different tensions. That's the main thing, 2 different tensions. Once stated, these equations can be solved simultaneously. It is important to make clear any notation used, particularly distinguishing which of the variables used represent which tension. Okay. So I'll be coming to that. All working should be shown. Error was seen to mix sine and cosine while resolving. That's another issue. And some candidates wrongly stated that the tension was the same in both. This method resulted in this such and such. An alternative approach was to use Lamy's theorem. We are not going to use Lamy's theorem. That is for 3 forces and that is an application of a sine rule. I never taught you that. We won't be using that. This is perfectly acceptable. Now coming back to this. Make sure that you tell the examiner. I have already told it through the diagram, but it's better tell it separately also. Tension in QP is denoted by T1. Tension in QR is denoted by T2. That's one approach, one thing that we have to take care of. Second thing is that we are taking all these angles with respect to the x-axis. That is what I have told you in the beginning of the syllabus. Therefore, the horizontal component is always cos. The horizontal component is always cos, and the other one is sine. So that is the main thing that people look for. Question number 4, we can see it for ourselves that this is a scenario of kinematics, and it's kinematics with constant acceleration because it is straight line graph. An elevator moves vertically supported by a cable. The diagram shows a VT graph. The graph consists of 7 straight line segments. 1, 2, 3, 4, 5, 6, 7. The elevator accelerates upward from rest to a speed of 2 meters per second. That is exactly what they are showing in the first part. Then travels at the speed for 4.5 seconds. So now 4.5 seconds like this, before decelerating to rest over a period of 1 second. That is the first thing. Now it's going up. What happens? Then the elevator accelerates the elevator remains at rest for 6 seconds. So this is rest. So this is rest. This portion is going up and this portion is going down. Upward velocity is positive. Downward velocity is negative. And all the information is given there. Accelerating to a speed of v downwards over a period of 2 seconds, travels at this speed, decelerating, and so on. First part is too kiddish. I don't know why they even asked this part. Find the acceleration of the elevator during the first 1.5 seconds. So during the first 1.5 seconds, that is first part, that is acceleration is naturally positive, and acceleration is change in velocity over change in time. That is 2 divided by 3 over 2. That is 2 into 2 over 3. That comes out to be 4 over 3 meter per second square. I'm just looking at different ways of writing this thing. 1/3 meter per second square or 1.33 rounded off value meter per second square. The best option is this one, and naturally this one. Since this is in a fraction which is improper, that is why I write it as a mixed number. Do not involve yourself into petty situations in which you have to take care of accuracy when you can easily get away with writing in the exact form. Now the second thing, given that the elevator starts and finishes its journey on the ground floor, find V. What does it mean? It started from ground floor. Let me call this as the ground floor. And it went up, reached this position, and then came all the way down. That means the displacement is 0. We know that this thing is positive. This is positive displacement. And positive displacement, and this is negative displacement. And the area above the graph should equal the area below the graph. So instead of even displacement, let's simply talk about the area. So this area of the trapezium, that is half, area up, that is half, sum of parallel sides, these two are the parallel sides. So one is 7 and the other one is 4.5. So this is 7 plus 4.5 multiplied by height, which is 2. This is area up and this is area down, that is half. These two are the parallel sides, 13 till 21.5, that's 7, 8, 8.5. And 15 till 20, that is 5. And the height is V. Of course, you will take the positive value of V because you're talking in terms of area. So basically, area up should equal area down. You would simplify and you will find the value of V. Third part. Read this part. What does it say? It says the combined weight of the elevator and the passengers on the upward journey is 1500 kg. So now they are talking about the upward journey. Assuming there is no resistance, find the tension in the elevator cable on its upward journey when the elevator is decelerating. This is the upward journey, but we are interested in the deceleration part. So first of all, what is the acceleration? Actually deceleration over here, naturally it's negative. This is 2 divided by 1, which is 2 meter per second square with a negative sign. Now remember, when we started this concept, I have specifically told you that the rule is, as long as it's going up, we would take the upward direction to be positive, and as long as it's going down, actually we would take the force that's pulling up to be greater. So this is the tension, this is the weight, it's going up, acceleration, irrespective of whether acceleration is positive or negative. So therefore T minus mg is equals to mass into acceleration. T minus m is 1500 into 10 is equals to mass into acceleration. T minus T equals to 1500 10 plus minus 2. I've taken common out. So 10 minus 2 is 8. That is 1500 into 8. This is the answer. Naturally, the tension will come out to be lesser than the weight component. That is why the acceleration is coming out to be negative. So as long as it's going up, we would start with this equation. T minus mg is equals to mass into acceleration. So that gives us our answer. Let's have a look. This is question number 4. So now question number 4 says, the question simply involved recognizing that the acceleration in the first 1.5 second is represented by the gradient. I mean, that's the first part, ignore it. No, wait a minute. An error made was to give the answer correct only to 2 significant figures. That's why I give the answer in fractions. Second part, in this part of the question, the most straightforward approach which was taken by almost all candidates is to evaluate the area and equate it to the area below the x-axis. That's the straightforward. This technique will produce an equation for V which can be readily solved. Most candidates made a good attempt at this question, but some were confused by the sign of V and often gave the answer as a negative value. Value of V was positive. When candidates considered these areas as made up of several different shapes, errors seen included omitting some of these triangular or rectangular shapes. The best approach is to consider the shape as two trapezia. Last part, in this part it is necessary to find the deceleration of the elevator by considering the gradient during the period 6 to 7 seconds, in which the elevator is accelerating on its upward journey. Many candidates found this correctly, but some thought that the deceleration was the negative of that part found in part A. Another error seen was to find the deceleration on the final downward stage. Once this deceleration is found, it is necessary to apply Newton's second law to the elevator and the forces acting at tension in the cable and the given weight. An error seen at the stage was to use an incorrect sign for the acceleration. So these are some of the observations by the examiner based upon the scripts provided. Question number 5. What is this question all about? This question looks like it is about friction, F max. Find the acceleration, coefficient of friction, and another coefficient of friction. Okay, let's see. A block of mass 5 kg is being pulled along a rough horizontal floor by means of a magnitude x Newton acting at 30 degrees above the horizontal. Without reading any further, I would break it up into its component. That is the first and foremost thing. This is x cosine 30 degrees and this thing is x sine 30 degrees. Since it has a tendency and it is actually moving to the right, therefore the acceleration, therefore the friction F max is to the left. What else is needed? We need the weight of the particle, which is of course obvious, but something even less obvious is the concept that we need the R also, because F max is dependent upon R. So this is R and this is 5g. So now this is the first part. Find the acceleration of the block. That is basic kinematics. U is 0. Displacement or distance is 2 meter. time is 5 seconds. Find the acceleration. So S is equals to ut plus half at square. Ut is gone. So this is 2, this is half, a is a, and t square is 5 square. So therefore 2 2s are 4. Acceleration comes out to be 4 over 25 meter per second square. Since this fraction will give me an exact value, so I can also go ahead and divide it. 4 divided by 25, that is 0.16. So this is 0.16 meter per second square. This is exact. Now it says, given that the coefficient of friction is 0.4, find x. First of all, r plus x sine 30, r plus x sine 30 is equals to 5g. Is it 5 or 0.5? 5g. R is equals to 50 minus 0.5x. Sine 30 has a value of this thing. So that's the first thing that's done. Now let's talk about F max. F max is mu r. That is 0.4 into 50 minus 0.5x. That is the second thing. So the second thing is about this. F max is equals to this. Third thing, it's accelerating. So x cos 30 is greater than F max. So x cosine 30 minus F max is equals to mass, which is 5, into acceleration, which was 4 over 25. And x cosine 30 minus 0.4 into 50 minus 0.5x, bracket closed, is equals to 5 into 4 over 25. And now it's between you and the calculator. You would simplify a simple linear equation and you will find the value of x. Now let's move on. The block is now placed on a floor where the coefficient of friction has a different value. So first of all, now it has a different value. That's the coefficient of friction. And that is actually what they're asking for. The value of x is changed to 25 and the block is now in limiting equilibrium. Find the value of this coefficient of friction between the block and this part of the floor. Now the question is the angle still the same? Seems so. So we have this thing. We have this floor. We have this particle. We have the forces as such. So therefore this is rightwards and then something like this. So this is like 25 Newton. This is like 30 degrees. This is 5g. This is r. And then the two components of that thing. So therefore one component is like this, one component is like this. This is 25 cosine 30. This is 25 sine 30. And this one is F max. So now r plus 25 sine 30 equals to 5g. You will find the value of r. That's the first thing, a numerical value. F max is equals to mu multiplied by this value of r. And it's in limiting equilibrium. That means it's about to move but not moving. So therefore, you would say 25 cos 30 is the same thing as F max. So 25 cos 30, whatever the value is, that is equals to mu times the value of r, and hence you will find the value of mu. So this question is also done. Let's move on to this thing. The question required candidates to use the information given in the question, namely the block travels this thing and so on, and made an error by assuming this was such and such. Okay, let's ignore it. The method of approach for this question involves first resolving forces on the block in a direction perpendicular to the floor. 3 forces were involved: the weight of the block, the normal reaction of the block, component of the X force. Some candidates forgot to include the effect of the component X, so incorrectly thought. This is what I'm interested in. Some candidates incorrectly thought that R is equals to 5G. They forgot the component. Newton's second law must be applied to the block in the direction of the motion, where the forces produce the acceleration and such. I think that's perfectly fine. In this part of the question, there is no acceleration. There is no acceleration since the block is in limiting equilibrium. However, the relationship does apply here. Hence, it is necessary to find the values of F and R in this new situation. Resolving forces such and such. Most candidates found the correct value of F. However, some candidates did not include the effect of the X component when determining R, and others continued to include the effect of acceleration. So these were two mistakes that people made in the third part. Okay, now comes